Hello, welcome to Kenteko AI. Today we are going to continue our series on the RAG, Retrieval-Augmented Generation. So without much ado, let's get into it. Okay, so for the past three lecture series, we were working on RAG, Retrieval-Augmented Generation. We have finished with the indexing part and then completed also the retrieval part. So this is what we are doing as a recap. From the last lectures. We have completed the embedding part. That means we have chunk our documents, embed them, and put it into the database. And the last lecture, we have also created the retriever component, and we are able to retrieve data from the database when users ask questions. So today, we are going to start with evaluating our RAG. Evaluation is one of the most important pieces of a RAG system or any application agent. You have to put this type of evaluation so that you can catch the real metrics that you're going to use to know if the system is working or not. And then, so today the lecture is going to be about evaluating what we have created, the retriever component, so we can know if everything is actually working properly. And we are using the framework RAGAS, which is Retrieval-Augmented Generation Assessment, and Pytest, which is a Python framework, which is used for unit testing, a major Python framework that is used for unit testing. So we just plug in the RAGAS evaluation to Pytest, and we can be able to run our evaluation in the continuous integration pipelines and be able to check to see everything is okay before any deployment. So we built everything on the Kente Code AI knowledge base. We have completed the retrieval part. So the retrieval part, we have created advanced retriever, which is doing all the stuff, the vector search, BM25, RRF, hybrid search, all those are done. So what I did here is take all that notebook, create one file called a retrieval pipeline. So we have a retrieval pipeline here, which is here. So all the things that we talk about in the notebook, they came up in the retrieval line. And so we have one retrieval pipeline. So this is the pipeline we are going to test. So on this pipeline, for example, if I run this pipeline and ask a question to the pipeline, like, can I take the AI for everyone course if I'm a teacher with no coding experience? So if I ask this question to this pipeline, it should be able to give me an answer, okay, using our retrieval pipeline. So the goal the goal here is basically we want to test to make sure that this pipeline is running. I just want to make sure the pipeline is running. I think it just failed because of keyboard interrupt. So yeah, so if I run the pipeline, for example, I ask this question to the pipeline. This is the response it gave back for that pipeline. It says, what question says? So it says, yes, you can take the AI for everyone course if you are a teacher with no coding experience. The courses are there for complete beginners and requires no technical background. Okay, and it gives you all the context that it got from the database in order to answer that question. You get context on AI for everyone, okay, and also get some other information before it's able to answer those questions, right? So our goal now is, okay, this pipeline, we say, okay, we have completed, but not too fast. We need to evaluate it and make sure this is actually working and the metrics are up to date. And if there's any issue, we are going to see it from the evaluation pipeline. So we take all the retrieval processes and put it into that pipeline. So that pipeline, that file is called retriever pipeline.py. So in this notebook, in the evaluation, we are just going to, import it, retrieval pipeline as RAG. We're going to import it, and then we'll be able to test the retrieval pipeline. Just want to make sure we are testing the retrieval pipeline. So That's what we are testing. So we import it and then we have it available. It, so it's just telling us all the things that we have in our retrieval pipeline. So now let's start with the evaluation. So the idea is this, that you cannot improve what you don't measure. So metrics are one of the most important things in measuring KPIs for any system. You need to use some kind of metric to say, hey, this is working good. You cannot just say, oh, I feel it's working good, so that's the case. A lot of systems fail because they have not been tested. There is no metric that they can use to say, hey, I have tested it, and these are the numbers. So for Retrieval Augmented Generation, RAGAS has been the framework that can be used for this particular testing. So for the Retrieval Augmented Generation, it is actually hard to test because there are different type of components. We have retrieval and generation. So if we want to test all these, we need to be able to test how the retrieval is working and how the generation is working. So there can be a retrieval failure. It means that the right chunk actually never got into the context of the question we are trying to answer, right? And there can be a generation failure where you got the right chunk, but the LLM did not use that chunk to answer the question. It has hallucinated and talk about something else. So we should be able to test these two components of the RAG pipeline. And because we cannot just say, oh, I feel this is a good answer, we are going to use RAGAS to actually test using metrics that are available to actually test these components. Okay. So under the hood, RAGAS is a, you can just Google RAGAS is a framework, retrieval augmented generation assessment. It has a lot of metrics that are there. You can use, but we are going to focus on four important metrics in RAGAS, okay, that we can use to actually test to see which component is failing. Is it failing on the retrieval or is it failing on the generation? So the four important metrics that we are going to focus on in RAGAS is context precision. That's the one we are going to focus on. The first one is context precision. The context precision is a fraction of the chance you retrieved. The chance that you retrieved, how many were actually relevant. So you can go to the database and get a lot of chance, but you want to see which fraction of them is relevant. That is your context precision. Okay, and this is happening at your retrieval level. At retrieval, you are checking to see if the chance that you receive, how many of them are actually relevant. The fraction, that is the context precision. Okay, yeah, you need to have a reference to know that, okay, this is actually is telling the truth. The claims that are made are actually true. So we talk about what is the reference. Then the context recall is another metric in RAGAS. So it says that, okay, did I get everything that I'm supposed to use to answer the question? That's what it means. So did you find all the information that is the answer is that is needed to answer the question? Okay, they are in the database. Did you find all of them? Yeah, the reference answer, does it have all the information in the context that you brought back? Does it have all of the information, or did you leave something behind? You did not get some of them. So that is the context recall. So, and the faithfulness basically means that you have all the context, okay, and then you generated the answer. The answer that you generated, the LLM generated, are all the things that the answer says coming from the context that you have. So if that is not correct, then that is hallucination. It means you got all the context to answer the question, but the LLM is hallucinating. So you want to check that. That is happening at your generation end of the pipeline, okay? And then the answer relevancy. So what happened? You got all the context, then you generated an answer, right, for the user. But the question the user is actually asking, the answer that you actually give to the person, is it relevant? Does it actually answer the question? Is it relevant or is off topic? So you can actually get all the context correct and get all the response correct, but it's not actually answering the question. So that is the part we say the answer relevancy. Your answer is irrelevant. And all these metrics, they are from 0 to 1, and the higher the value is better. Okay. So you can see, for example, if you have high faithfulness, the faithfulness is high, means you got everything grounded, right? Everything in the answer is grounded. But you have a low answer relevancy, it means everything is grounded, right? You got everything in the context, you give the answer, everything is correct. But low answer relevancy means it's grounded, but it's not answering the question the user has asked. Okay, right? You can have a high context recall. High context recall means you got everything that is needed. You got everything that is needed from the database, but low faithfulness. It means the LLM did not answer the question based on that because it ignored it and just say something. Okay, so you have to look at them and see which part do I need to go and fix. Okay, if you have a low context precision, that simply means that the prompt has a lot of junk. You did not get all the most important thing, or you did not have the most important thing in the top K, the top value. So you might have to do re-ranking and make sure that the most important things are always at the top. And you might have to title your top K so that you don't bring a lot of junk. Okay, that is your precision, because the precision is a fraction. Right? It's a fraction of the most important chunks that are in that particular number of chunks that you are sending to the element. That is your precision. So you have to look at it like that. So the RAGAS framework, you can just install it. Pip install RAGAS. RAGAS. So if you go to RAGAS, the framework is a very popular framework. It keeps undergoing a lot of changes nowadays. They are migrating to a lot of a lot of migrating to latest document. I mean, libraries, how to use all the libraries. So at any point, you might be seeing different ways of using the framework. But when you go to the framework, you can see a lot of information about all the metrics, how to install it, and all that kind of stuff. I don't want to go into all that stuff. I just want you to understand how the metrics works and how to use them. Okay, from how to use the metrics in Radar. And only the top, this particular, we are only interested in understanding that those four metrics. Once we understand those four, we can use any other metrics. Those four are actually the most important ones most of the time. So the RAGAS framework is built in a way that has this kind of stuff. We have metrics object, okay, metrics object. So the metrics objects will have like the faithfulness, the context precision, the context recall, the answer relevancy. So this type of class, they use what? These metrics, they use LLM as a judge. Behind the scene, they basically use an LLM, ask a question to the LLM and give a score. That's what they're using. So those are the metrics objects, okay? Some will use only the faithfulness, the context precision, and the context recall. Will just use LLM, a regular chat LLM, but the answer relevancy needs an embedding model. So it will use an LLM and an embedding, because the answer relevancy have to actually check the answer in the vector space. Your answer and then the question the user asks, they have to be checked in a vector space. So it uses an embedding model. So that is this particular answer relevancy metric. So these are the metrics that the RAGAS framework, these metrics, then it has evaluation data set. So basically it has a structure, take it like a container that have things that, it has a format. It will have the user inputs, like the response, the context that is retrieved, and then the reference. We talk about it. It has a data set, take it over a dictionary that have that kind of format. That is the evaluation data set. It's an object evaluation data set. And then it has an evaluate function that you can use to run the batch of everything that is in the data set and give you back a table. The table will have all the questions that the user asks, then all the metrics values, like what is the value of the faithfulness score, what is the context score, what is the recall, and then what is the answer. It will give you values to that, and then you can see how your LLM is performing. Okay. So the way it is that it breaks the retrieval and the generation apart, so you can see from these metrics which part of your LLM is having issue, right? because the retriever is there, the generation is there. And these metrics, this because is it faithfulness, this is generation, like faithfulness. That's the generation side you see. You see the generation side, you see generation, the faithfulness, and answer relevancy, that's the generation side. Then the context precision and context recall, if these things are low, then it is the retriever side. So those will help you to know which part of your RAG is having problem. Is it the retriever or is it the generation? So that you can go and troubleshoot at that level. Well, so RAGAS will help you get that right. So as far as you install RAGAS, right? You install RAGAS, and then you once you install it, it's available. So for example, I've installed it already. So as a peep show, no, peep show, you see, I already have it. Peep show RAGAS, I already have it. See, I have installed in this. I have RAGAS. What RAGAS is that? RAGAS 4.3. Okay, so I have it in my requirement.txt. I have the RAGAS here. So these are all the packages. I have RAGAS here. But the one I installed is this one. This is the latest at this time. This is the latest RAGAS that I'm using. So I already have it. So once I have it available, so I can use the components that are in RAGAS to continue my work. Okay. So these are the components we are going to use from RAGAS. So we are using LangChain OpenAI. We need an embedding model, I say, for the answer relevancy. From RAGAS, we need the evaluate. The evaluate is the function that can run the batch process to evaluate everything. And then we have LLM factory. This is the new way of RAGAS. LLM factory helps you construct your LLM that you're going to use for the as a judge. And then LangChain embedding is just a wrapper against the around the open AI embedding that you can use. So don't worry about these things. You just need have to use it. So RAGAS, we got the faithfulness, the context, and the context recall, context precision, and then the answer relevancy is the same as the response relevancy. Okay, so that's what it is. So we create the evaluator LLM, the LLM that the RAGAS is going to use, and we use this particular library like this. You have to give it the model, okay, and then the open AI client and the temperature. We set it 0. We don't want it. We want it to be strict. And then the evaluator, the embedding model, we say we use the wrapper, LangChain embeddings wrapper, and then we use the open AI embeddings. We call the embedding model that we are using, that is this one, and then we give you an open AI key. So we create the two objects, that one for the LLM and one for the embeddings. And then the metrics we want to we give it as a list, right? So these metrics here, these metrics are all classes. So if you want to create an instance of them, you give the LLM that you want to use. So you want to create faithfulness, you give the LLM that you want to use. You want to context recall, you give the LLM, and then the context precision, you give the LLM. And for the response relevancy, you give the LLM that you use, and then the embeddings one, the LLM you're going to use for the embedding. Okay, so those are the tools. Okay, so those, then we have this the setup ready. All right. So now we have the RAGAS setting, but we have to have a data set for test. Right, we are going to test in a building RAG. This is what we call the golden set. Basically, let me show you what it is. The golden set. So I have a test folder that I put the golden set in here. Okay, this is just a list. So the golden set basically is a question that you create. It can be experts, domain experts, that they'll create questions from the document that you are using for your RAG, from that particular a question, and what is the ground truth to answer that question. What is the answer, the ground truth for that question? That is called the golden set. This is what you are going to use for evaluation. This is the test set. So for example, I created this one. You can create any number of them. The more you have and the better they are, the better your evaluation data set, the evaluation is going to be. So the question, I say what is Kenteko AI, and then the ground truth, then what it is. So they are, the question and answer, they are set like that, right? Question, a dictionary, a question and answer, a question and answer, and you create them as a list. Right now I'm just storing this in JSON, this JSON here. Okay, this is I will use the JSON setting like this. So you can give this to somebody who is an expert in the domain, and the person will be able to provide this type of question and answer. You need this answer to this particular data set to be able to actually evaluate your data, your RAG system. Okay, it is very important. So now that we have that, so we load the golden data set evaluation there, because we need, that's what we are going to use. So we use the golden data set is in test. So we load this, we load it in this test folder, we load it here, and then we see this one is just showing all the questions that are in there. Okay, because we will use that golden data set, we take all the questions, we will take one question, ask the LLM, and then we get the response, and then the context that came back. We will take all that and then the golden truth and create an evaluation data set. So we have all that, okay? So the next step is what? So we have all the golden set, right? Here we just have 8 questions in there. So we now go and we will generate the answers and collect the context, okay? Because RAGAS you need here, in order to have the evaluation data set, we need 3 or 4 things together. User, the input, the question the user asks, the retrieve context, those are the things that you get back from the database, the response, that's the response the LLM generated, the reference is this is the reference, this is the golden truth that you have in your data set, this is your reference, okay? That is what the reference is. So you need that to create the data set for the RAGAS testing to be done. So in order to create that, right? So in order to create that data set, the evaluation data set, so let's create a function that can build that data set. So what it's going to do is going to take all the golden set. So let's say we want to build evaluation data set, right? It's going to run the golden questions through a retriever plus the generation and package the result into a RAGAS evaluation data set. That's all it's going to do. For example, we have samples, right? We are building the evaluation data set. So for the item in golden data set, so this item just means, because this is a list, right? So if you say for item, it's going to, each item will be this dictionary, okay? It will be one dictionary at a time. That will be each of the items. So for each of the item in there, we can say the answer and the context. That is calling this for particular uh, function in our RAG pipeline. This function gives you what it returns. If you go this, when you call this particular function, when you say generate this, it gives you back. It gives you back the response from the LLM and also the context. So we are just calling that function directly so that we can say this is the answer, this is the context. When we call this particular generate answer, we will give the question that we have, because this item will give the question that we have, and then we will use the retriever. The retriever can be a naive, a vector search, or the advanced retriever that we are using. So we want to be able to compare what is the result from the naive, like simple vector search, and also the advanced. So in our advanced retriever that we have multiple steps that we did, and we want to be able to have numbers to prove that it is worth it doing actually the multiple steps, because those multiple steps cost more money. It has latency. It means the more steps you are doing, the more time it takes for you to generate the answer. So you do all these things to evaluate, to see what are the steps that are actually needed. It's like a knob. You are tuning it. If this is working, then it's good. Is it giving better answer? So if some things are not necessary in that multiple step in your advanced retriever, if it doesn't make any difference, then you can just take that step out. So those are things you do as you are running those experiments when you are doing your development to see which one will give you the best value. Okay. So here, after we retrieve the answer and the context, we have a list here. We have a list. We are getting the list. We are adding everything. This dictionary set, okay, this list dictionary, of the user input is the question they ask, and the retrieve context is all the context that you get from the LLM, and the response is the answer the LLM generated, and the reference is the golden truth that you have in your data set. So when we have all these, this will be a list of these dictionaries. Okay, we are generating this list of dictionary. Once you have this list of dictionaries, the evaluation data set has this method on it. From list, and you give it that list of dictionary, then it will generate the evaluation data set RAGAS needs for running against. Okay, so for example, so we have this to build the evaluation data, because you have to build the evaluation data set and then give it to RAGAS with the metrics, and it will run the metrics against the evaluation data set. So if we have that now, so let's say we want to build a data set for our advanced pipeline. Okay, we have the advanced pipeline. That's what we just looked at. The advanced pipeline, that query rewriting, multi-query, hybrid, RRF, and rewrite is so advanced. So we want to build a data set for that particular data set, that pipeline, by asking question and getting back the answer, and then form the evaluation data set. So advanced data set equals build evaluation data set. Okay, then you give the retriever, because this function, this build evaluation, it takes the retriever that you want it to use. You want it to use the advanced, or you want to use the naive. So here we are saying use the advanced one, because the advanced, we build the advanced data set. If you see, this is in our advanced data set. You see, this is the class advanced we built in the last lecture, and it has the retriever. So if you call this function, it will run every step. It runs the rewrite, the expansion, the hybrid. So this runs everything. So we are basically here, we are calling and say, hey, run that particular instance, that method, that retriever, and then this is just a label for it. Okay, so now once it has this, it's going to give us the advanced data set. So okay, so it built it, and then all the questions, it will ask the question, get the answer back, and then build back the evaluation data set from that. Yeah, so now we have that evaluation data set. Now we go and then run the RAGAS against that evaluation data set. So we are going to run the RAGAS evaluation. So the RAGAS, you use evaluate, that's the method. You just use that and give it the data sets and then the metrics, and then it will run against all the questions and answers that are in there and generate the metrics for you. So if you look at this, right? So we run the metric, it's going to run every metric that you have in your metrics. So we have a list of metrics, right? We created a list of metrics at the top. So it's going to run against each of them and give you a table of values that for those metrics. So if you want to see the result from the advanced data set that we created over here, what we do is we just call the evaluate, right? The evaluate function takes data set. If you click on here, it tells you what it needs. It needs the data set, it needs the metrics, which is sequence or list, and then you see, so we call evaluate function. We call data set is our advanced data set. The metrics is the metrics that we want to get, and the raise exception is equal to, this is just by default, this is false. But raise exception is equal to just what we want. If there's any failure, we want a no silent failure. We want to see everything. So when it runs, these things takes time, so like 2 minutes, and they are real LLM calls, so I can't be running all the time. So when the time you're running, this they call. So it will run and then generate all the answer for you. Okay, in this advanced, it will give you back the advanced result in there. So with that, you can see what is in the result. So here, the advanced result, what comes, that object can be converted into a pandas data frame. Okay, just pandas data frame, so you can look at each of them. So you just say that advanced data set dot to pandas. Okay, then it gives you a data frame, and that data frame you can see the user input, the LLM content, the record, the faithfulness, the answer, whatever metrics you gave, it will be in this particular data frame. So we write out the data frame. So look at the data frame. This is how the data frame look like. So this is the advanced. You see, per question RAGAS cost the advanced. Okay, the first thing is the user input. That's the first thing. This is what is coming. So like the first question is what is Kente Code AI? Okay, so for that particular one, you see the metrics LLM context precision with reference, and then it will give you the value for that, which is one. Okay. Oh, how do I have this? Okay, here. This goes here. Okay. So each of the question, the metrics will be here. The value, the questions, you see, the metrics are at the headers. You see, context precision, context recall, faithfulness, and the relevancy. Then each of the answers, what score that metrics have will be under it. So you can see this, you can see all of them. Some of them are 1 1, some are 0.7. Then here is 0.83, this one is 0.85. You see, all of them have different values, right? So that's how you see is it gives you, like, for example, what is Kente Code AI? It's a LLM context precision is one. One is the highest. It means that when you ask this question, the context that the user the model has provided and the question has been answered, if it looks into the reference, okay, the reference, okay, what is Kente Code? You see this? You see this? What is Kente? This is the question. And this is the reference or the ground truth. Okay? This is the reference on the ground truth. It means the context precision means that when you say what is Kente AI, and then this is the reference. Kente AI is this. All the context that the model brings to answer the question. All the context that the model brings to answer the question. If the model checks all the things that are said in the reference and check into the context, every claim that is made in this reference can be found in that part, in the set of context that the model bring back. Okay, so it means that when it's returned the context from the model, okay, all the context, the LLM has a judge saying, okay, this is the ground truth. Okay, this is the ground truth. It will look into the ground truth and check to see if everything that is being asked here is actually in that particular context. So this, if everything is there, is one. But if it's not there, somewhere there, then that's how the marking is happening. Okay, that is precision with recall. Okay, so all these particular, oh, what is it? It's at the top here. So like the faithfulness, for example, it will see the response that the LLM gave, the response the LLM gave, faithfulness. It will check the response and see all the context and see everything that the response is saying, is it actually in the context? If everything is in the context, then the faithfulness is. If not, it will be zero. And then the answer relevancy, right? This answer relevancy is going to see the answer that the user gave, the answer that the model gave to the question, and the question, this question that is being asked, is that answer and the question they gave, is it relevant? Is it relevant to the answer? Is it relevant to the question? And that is going to give you a mark for that. Okay, so that's how that works. Okay. Okay, now this is a situation here I was saying. Okay, so not everything is going to be one or all good. Then, if it's all going to be good, then we don't even need evaluation. But this is something I've observed during the lecture. So, if you see context recall here on this question, who is the founder of Kent? What is the thing? Yeah, the question said this. He said, who founded Kente Code AI and what is their background? Right? This is what it says. And then, if you look at this particular thing, the concept precision, the answer, the model gives the answer, and then everything is a one. Okay, but the context recall is zero. Okay, context recall is say it takes the reference. Okay, it takes the reference, this particular reference. This is the ground truth. Okay, this particular thing, and see whatever is in the reference is going to check to see everything there is 100% in the context that the user gave back. Okay, if it's not there, then we are going to say, okay, so for example, this one, the claims that are made in the answer, the user in the reference, like this particular claim, like what is that question? Who founded Kentekut AI? Yes, you see this, who founded Kentekut AI, and this is the reference. The reference say Vincent founded Kentekut AI. He's a staff data engineer and AIM engineer with about 12 years of experience. So this reference, okay, the context that comes back from the database, this metric is going to make sure that everything here is there directly in those contexts. If it is not there, then for example, this one, if it's not there, it cannot find it. This one is zero, no temperature is zero. So it's very strict for this particular one. We set the temperature to zero. So it's very strict. It's going to look to make sure that everything in the answer is directly in the context. If it's not there, you get a recall of zero. Okay? But the context precision is still context precision with reference. The context precision is still one. Okay, because this one means that the model is actually able to get a context that answers the question. But the context it got, the problem with this is that the context it got has been truncated. Okay, the context has been truncated. It's not full. It got a chunk, but in that chunk, the context is truncated, but the model is still able to answer the question. So the context recall is saying zero because it's looking for 100%, everything has to be in there. But the context precision say, hey, it has what it needed to answer the question, so it's good. Okay. And then you can see all the other rest of the metric. So the takeaway from this particular thing is that when there is an error, when you see these particular numbers, okay, some are zero, some are one, you don't just take the name for context record. You have to actually go back and look at what actually came out. You have to actually go run the particular question like this, see what is coming from the model, from the database, look at it and see what is the question and see what actually is causing it. So in this particular case, it's a chunking problem because the chunk is splitting off some part of the information that is needed to make it 1%, to make it so that everything in this particular reference is in the chunks that are retrieved. So they are cut off. That's how. This is what I realized when I was looking at this. They are cut off, so it was not getting everything when you retrieve it. So that is why we got a zero for this particular case. Okay, it's something that is what your those are some of the things that evaluation is going to catch. Maybe your chunking is not correct, your retrieval is not correct. Once you see this, you have to go back and find a way to improve the system. That's the whole point of running your evals, to make sure that everything is working as well. So in this case like this, you might have to go back and rechunk the stuff to make sure that everything when they come, they look JJ, so that you can get everything correct. Okay, all right. So that the take when the context recall, like when it's zero like this, these are some of the things that you can try to check. The fact probably was never ingested. Maybe the data is not in your database. That's why you need to actually go there, get everything for that particular question, look at it, and look at the golden truth and see, okay, is there anything missing? Then from there, it will tell you maybe your chunky has problem or something else is wrong, okay? Or your top K is not getting some of the things they have left in the data. If the thing is there but it's not coming, then your top K is not getting it. So maybe you have to do re-ranking to bring the most important chunk at the top. So these are some of the things you have to go, right? So you might be at the fact was never ingested. So nothing relevant retrieve at the top K. So you have to add a missing content to the source document and re-ingest. That might be the case. Or retrieval rank the right chunk too low. Is too low. So what happened? The chunk exists in the index, but it isn't in the top K. So you have to go and do a tune up for the top key, and the candidate improve the query rewriting and re-ranking, whatever you have to do to get the right chunk at the top so that it will show up. You have to go back and do that. Okay, and in this case, the chunk is corrupted or truncated at ingestion. This is the case we have here. So the right chunk is actually retrieved, but the judge or other human looking at it, they are making sure that everything have to be in the chunk, because it's not there in the chunk. It says no, zero. So you have to go back and fix that chunking to make sure that when the chunk comes, everything that is needed to answer the question is in that particular chunk. Okay, so that is that part. Okay, all right. So that's the idea. So that when you are doing the evaluation, you look at the metrics, you see the result, you need to figure out what is causing the issue and then go there and try to solve the issue. That's the whole point of the evaluation. And then there is something regression. Once you put code into production and then you make changes later, when you run your evaluation and then the metrics change, they fail, you know that okay, something has gone bad. I've made some change that broke it. So you go back and look and say, what kind of change did I make that cause this regression or something to fail now? Because before it was passing, now you make some changes. Maybe your chunking or the model version has changed. Anything has changed. These metrics will make sure they catch it so that you can go back and then be able to look into it and try to fix it. That's the most important part of the evaluation. All right, so this is it. So better retrieval means better scores. So consider naive, where you just do a vector search, and then advanced, where we are doing all the rewriting, the expansion, the re-ranking, all the hybrid search stuff going on. Is it better to use the naive, just simple vector search, or advanced? You cannot just answer that question and say, oh yeah, advanced, I'm doing this and that, so it's good. That is not, you need to show numbers. So to show numbers, you do your evaluation on the naive, the vector search, and then you do your evaluation on the advanced, on all the stuff you are doing. Then you look at the numbers, the metrics that we are looking at, and see which one actually give you the best result. Because you have to be able to justify why you are spending money rerunning, re-ranking additional models, more time for the answers to come up, because now you are doing hybrid search and all that stuff, query re-rank. You need to be able to give a reason why. There's trade-off. There is trade cost. It costs more when you are doing all this stuff. So whenever you are doing this stuff with the metrics, you can prove to your stakeholders that, hey, I have to do this because it has to pass this particular trade-off that we say the model cannot hallucinate. So I have to do this and that. That will give you a good answer to give to your stakeholders. Okay. So for this particular one, we can run it for naive. So we will run it for naive, and then we will also run it for advanced. Then we can see the metrics. So that is what is going. So when we are building these things, you do one at a time. You are doing an experiment. You do like query rewriting. Like maybe you do rewriting. You see how everything comes out, the metrics. Okay. Maybe then you add multi-query expansion. You see how everything come out. Then maybe you do first you do vector, you do hybrid. Every one of them you add, you have different combinations, and run the experiment and collect all the metrics for them. Then this experiment, all the output, you are going to use this to determine which particular combination. It's like you are training the system. Which particular combination is actually good for my RAG system, because that's the only way you'll be able to get the best. It's like in machine learning, we call this parameter tuning, also hyperparameter tuning. Yeah, you tune them, the parameters of the model, so that the model gets better. Yeah, so it's just like that. We are using experiments here, using evaluation to see different ways, techniques, and then we choose the best way to deploy eventually, because we have answers, we have metrics, we have numbers to show that they are performing better, right? So let's do an example like this. We have the naive data set. The naive data set, we are just going to we are just going to run a vector search, just regular vector search to generate the evaluation data set for that. That is the naive data set. So we do that, okay? So you see here we're just doing a vector search. This is an inline lambda function. Inline, just doing vector search. It's going to give this function to build eval and then do a vector search, okay? And then this is and give us the naive data set for the eval, okay? Then we evaluate the naive results, just like we did the evaluation. Then we get all the metrics, right? So we get all the metrics we have. These are the metrics we have, okay? We convert the naive data set also to pandas, okay? And then we can see all the information about it. Then we can find the mean, because you can have a lot of data set, like the question answer. You can have a lot of that, and looking at each of them is hard. So at the end, you can find the mean of each of the metrics, right? So it gives us a pandas data frame, so it's easy because it's a pandas data frame. We can find mean of each of the columns. Okay, we can just get mean of the metrics columns. These metric columns, we can calculate the mean for them. So we have the data place. We put the metric columns dot mean. That will give us only the mean of those columns. We want to get that, okay? That's what naive. The advanced also, we get only the metrics column. We get a mean for them. So after that, we can just print what actually came in. So we ran it, okay? Then let's go and print the result. Okay, so now you see this is all along. So this is the naive. This is the naive one. When we run the naive one, this is the outcome from naive at the top. You see that this is the naive one. You see naive one is also here. Let's look at the raw answers for naive. Okay. You see, some are 1 here, some are 0.5. This is 1, this is 0, is 0.3. If you just look at this, you see that the advanced one got 111, a lot of them, and then naive also got 0 for the same issue we have. So, but that's what I say. It's hard to see each of them. So you can do the mean for each of them so that you can compare them. So if we take all of them now, we take all the metrics, okay? Then for the naive, we calculate the mean for each of them. And then for the advanced, we can calculate the mean of them. So now it's clearer now. We see that, okay, naive, this particular metric, 0.5 and 0.95. That's a huge difference, right? That's a huge difference. You see this one, and then you see this one, 0.85. That's also, so you can easily tell that, okay, the naive is not performing, just the simple vector search is not the way to go. Then you can concentrate on the advanced, okay? But then the advanced too, you can then see different configurations. Should I be doing query rewriting? Should I be doing expansion of the queries? Should I be doing hide, hypothetical document embedding? Should I be doing all those configurations? And then when you see all those type of settings for different runs, you can say, okay, this combination is the one I'm going to push to production. Okay, then that combination becomes your final RAG pipeline that you're going to put into production. All right. So what have we done? We went through. We've seen how all the metrics can be applied, to the data set. And our advanced pipeline has everything that we have. They just have everything for now. But that's why I say you want to go forward to production, you take that advanced pipeline and have different combination and test it to make sure that, okay, everything is working. Okay. But let's go back and see what happened. You see, in this case, what we are doing now, we are in this notebook, we were running everything by hand, seeing the result, comparing it, and see if it's good or not. Okay, that is good. But in production, when you need to push this code and have it running automated, the testing going, when somebody make changes, once in a while, you want to make sure the system is still working as expected. The framework that normally used, the most popular framework for testing is Pytest in Python. Okay, Pytest is the framework. So we want to go next and see how we can actually add the RAG into the Pytest framework. Okay, the Pytest framework is there. It's a popular Python framework. You can just go say Pytest documentation and you can read more about it. Okay, you just say pip install Pytest. The whole idea of Pytest is this. Okay, so you can write functions to do things. You write functions to add things, to subtract it, to do a lot of work in Python. Then all you have to do is you want to test those functions, you create tests and then to test those particular functions. This framework gives you a simple way to just test anything you want to test, and then we use it in our in unit testing for normal codes all the time, and the same applies. You can use it in RAGAS. Okay, so what is it? Let's see. If you are new to PyTest, this is see this. You have a test example, right? Yeah, let's say you have this test. Okay, this test example, a file called test example, and it defines adding two numbers, a plus b, it will return a and b. Okay, so if you want to create anything to test this for in PyTest world, you just put the name test underscore, then you can put whatever name you want to give to the test. Okay, and then you say asset, then you call this function. Okay, you call the function, supply the values to them, and then equal to the value it's supposed to give. So if I say add, it's going to say 1 a plus b, right? So if I say a add 2 plus 3, it has to be equal to 5. This is the result, right? What happened is when PyTest run, it looks into all the folders and the subdirectories and look for anything that say test underscore as the test. Okay, and then it will run this. Accept means that this thing has to be true. That's what it is. If it is not true, it will fail. So that's all it's doing. So if the accept means that this statement has to be true. If this statement is not true, it failed, then this test fails. So you can write so many tests, just put test and then the name of the test, and whatever the test will do, then you put the asset, making sure that that thing is true. If it is not true, it will fail. Okay, so like for this one, will pass. So you can write another test, then you put whatever it is, like this, say I said add 2 plus 3 equals 6. Obvious 2 plus 3 when you add them is not 6, so this test will fail. So you can write so many tests to test the same function, whatever test you want to test for it, you just put test and do whatever you want to test about the thing. So that is what PyTest does very well. Okay, the framework make it so easy to test things, right? If you just write any file and put anything, it files with test. You see, test underscore any name dot py. Okay, if you just say PyTest, you create anything that says test underscore the name of the file. Anything in that file that has this particular test underscore something, it will run that test. So let's go and see how we are going to use it. Okay, a little bit into PyTest. Okay, PyTest discover the test. You don't say, oh, these are the tests I want to run. PyTest will discover the test. If you say, for example, I have this folder called test. I have this folder test. Okay, if I say, if you want to write PyTest, you just say PyTest. Well, if I'm in the terminal here, and I say Python, did I say PyTest? When I say PyTest here, okay, PyTest, okay. When I say PyTest, what happened is from this root directory, okay, the PyTest will search for anything, any file that has the name test underscore whatever dot py. In these directories, subdirectories, it will go there and look for it. If I say PyTest. So for example, in here, I have here and one file called test underscore rag. This is the one we are going to use. Okay. So it will go through, when I just say PyTest, it will go through from the root directory, it will check and the subdirectory and look for any file that say test underscore. Then in that file, it will go and look for any function that have test underscore inside in the function, okay? Then it will run that function as the test. But if I want to point it to a particular folder, like I want to run it only the tests here, or maybe the tests are here, or wherever they are, I can point it to that and just say the Pytest, then I give the folder, wherever location I want to run it. Like if I say Pytest test, that means I'm saying do not discover anything else outside, just go into that folder and this subdirectory and look for the test files that are in there. That's how Pytest works, okay, in general. So and that's how it discovers the test to run. It will get all of them and run it, okay. Just to piggyback a little bit back about the Pytest, we have features in Pytest. So a feature is basically something we want to reuse in our session. Okay, so a feature, so we are not doing Pytest studies here, but just want to give another some. So when you create tests, okay, they are normally in config test, okay, features, okay. So these are some files that Pytest uses. Config test is the one of the most important one, and then we can see in the root there's pytest.ini ini file, okay. But the config test normally will define the features, okay. It will come like this at pytest.feature, okay. Scope equals session, it means features are things that are defined once and can be reused by anything, okay. So for example, if I say at pytest.feature scope equals session, then I define this function golden set. This function return load golden set, okay. So load golden set is a function that load the golden data set. So any other test that says golden set, okay, it calls this, what it calls this feature is defined and anybody can just call it by just saying golden data set. Especially when it's in the config test, everything here is run and is available to anybody to use. It's automatic in the config test. Anything here, all features are as well as in the config test. The config test is a special file that anything that is defined as a feature is automatically, there's no import, there's nothing. It's automatically available for Pytest that, okay, all the things that are marked as a Pytest feature, the moment that this function is available, as long as it has this marker on top of it. So you see this marker, they're called decorators. As long as it's decorated like this, it's decorated like this, it means that this file is saying that this particular thing is created once and it's available for every test. So Pytest is better. So those are called features. Reusable setup, they're handed to your test as a parameter, so you can just use it, okay. Then there's config test, that is the file we have here that features every test file can use, right, with zero import once you have it in there. And then there is parameterized, where you can define one test function and it can be used for many test cases, okay. Then there are markers. So when you have tests, you can mark that, okay, you give it a marker like LLM something, so that later on you can only execute specific tests by only calling their markers, or say not their markers, then they will not be run. So that's how that works. We go to let's go to examples and see how we use it in our code. Then that is more solid, okay. Okay, so we are testing the RAG eval pattern. Okay, we have the golden set data set. Then we have the config test. So if we see the config test, we see it defines some things that we need. Is okay to in order to make this pipeline run automatic. Okay, it defines how we are going to set up our RAGAS. Okay, RAGAS, the way we set it up in the notebook. It gives all the metrics that we need. Okay, it has it over here. Okay, it gives the path to the path to our golden set, and it defines what to put into our ENI. So this file is called pytest.ini. It tells you what markers. You see, this is ENI file. This is the top. It means that Pytest uses this. If there's another configuration, you put another name here. But this is saying that, okay, Pytest markers, this is it put this in here, and it say adopt -m markup, not LLM. Okay, so this default setting means that when you run Pytest without saying Pytest, without any configuration, do not run any tests that have LLM as the marker. So let's see how the marker look like. So if we look at this, we are looking at config test, right? So config test says that, okay, add, say, Python's configure is used to put in things what going to be in this particular file. So it says config.add unique value line markers, which we see over there, LLM calls this information. Okay, this information is added to that file. Okay, as a marker. Okay, markers. So that way you see in the ENR, you say markers equals here. Okay, okay, adopt equals that. Okay, let's see that in the config test again. Okay, it add those markers in there. Okay, so then it define, this is just a regular function, how to load the golden set. Okay, this is config test, how to load the golden set. It say json.loads our golden set path dot read test. It's just going to read all these golden set. So this is just a regular function, but here is a fixture. A fixture is identified by the decorator. So at pytest.fixture scope equals session. In this session, when it's running, the application is running that session, it creates the fixture once, and it's available for every test to use it. Okay, it will not recreate it just one. So for example, it will load the golden set data once, and every test that need the golden data set will have access. It will not go back and be reloading and be reloading. That's the whole point. Okay, it does it once, and it's available for everybody. Those are called fixtures. Okay, when you define something as fixture, it is done one, it created once, and it's available for everything. Okay. So like this is also another feature. Okay, it has it gives you back the retriever. Okay, a rag retriever. So when you say retriever, it gives you the rag retriever, and it's available for anybody who say. So if you want to use the feature, you just have to call the name of the feature, like this retriever. Okay, and that's it. It will give you back the object. It doesn't have to go and recreate or do anything about it. So that's all about. We are not going into Pytest, but we just need to actually know how to use it for our evaluation. Pytest is part of Python. You need to know how to learn it from Python. So this is what our project. We have the RAG retrieval pipeline. So this is the pipeline we have. This is all we are trying to test, and we have the ENI file, and we have the config test, and then the golden set, and then the RAG. The test itself is defined in the test RAG quality. Okay. So look, config test features for the retriever and RAGAS metrics built once per session. Okay. Pytest underscore configure registers the LLM marker, import retriever pipeline as RAG, results because Python -m Pytest test, run from the repo, put the repo. We have to, yeah. But this is just saying that this is what the config test.py is, and it helps you to define the features, and it run once, and all the features are available to you. Okay, that's what the config test does. Okay, now let's go to test RAG quality. So we say that for the Pytest, it needs to look for the files that say test underscore. Then those are the files that contain test. Okay, so our testing our RAG, we put the test to perform in test underscore RAG quality. So this file contain the test. How to test our RAG? Okay, this file will contain it, and when Pytest run, it will find this file and go into it and see functions where it says test underscore the name. Okay, so for example, let's quickly go and see. You see like this, test underscore answer is grounded and relevant. Okay, so test underscore. So that's the function. It will be looking for that function, test underscore. Okay, so let's see how are we testing our RAG quality. This is the main thing. Okay, so this is RAG quality regression suite. Golden set questions to RAGAS assertion. Okay, we have the golden set, we have the RAGAS assertion. So this simply means the golden set. Remember when we ran in the in the notebook, it gives us numbers like 1 for precision, 0 point something for recall, something for faithfulness. It gives us those numbers. We can look on it on the screen and say it's good or not. But how do you automate it so that if the number drop below some number, you say there is a failure? Right, so that if some automation going on to check and see, is there anything wrong, is there anything, humans cannot go every day and be running this notebook and be looking at the numbers. So to automate this process, that's what RAGAS is actually trying to do. It's going to be able to do the same process. It's going to be able to run all the metrics, get the values, but then you are going to define thresholds that if it meets it, then good. If it doesn't meet it, it will fail, because RAGAS Pytest has the thing asset. You set the threshold for each of the metric. If it doesn't meet it, the asset will be wrong, so it will show failure. Okay, so let's read this. RAG quality regression suite golden set questions to the RAGAS assertions. Okay, so every test in this file calls a live LLM. We are going to, because we need to get the answer. Okay, and the live pine code index, we have the data in line code. So they are all marked LLM. So this file, this is LLM. We say markers LLM. This test can contain a lot of tests for even our ETL to index the data and all that stuff. But if we want to run only the LLM components, that's what the markers are for. It allows you to run only some component. If you don't want the, if let's say you are just testing the ETL, you can run it and say, do not run the LLM markers. So it will only run the other tests. Okay. So here we are saying that, okay, we want to run only this test, we marking it as LLM. Okay, so LLM means that run only LLM component. Okay, so we have the Pytest, we have everything, the retrieval pipeline, the golden set, RAGAS. Okay, so now this is what is important. We set thresholds. We say the context recall, the minimum is 0.5. Faithfulness, the minimum is 0.5, and answer relevancy, the minimum is 0.50%. But these values, for example, in some cases, I had to select 85%, 70. So this will come from experimentation to actually know which values, that thresholds you are actually going to pick, because it's going to be trade-off. Like if it is at too high threshold, you're going to get a lot of failures, but the answers are actually correct. So you're going to see from your experimentation which numbers, but this one is just default. It cannot be 0 or anything less than 0.5. That's the default most of people will set. Okay, but from experimentation, you can get the right threshold. So I have this threshold set for each of the metrics that I want to be able to track and make sure that my system actually is performing well based on this metrics. So what happened is, now what I can do is this, right? I can now go run my LLM, collect all the results, and check, make sure that they are actually meeting the threshold. Okay, so this place is just, we are creating a function that can help us get the result without multi-query use, because multi-query use sometimes can create variations. So for this particular test, we want to use only one query, the query the user asks, and go and then get it, okay, and get the answers for it. So we are taking them out. So to avoid flakiness in the test, that's how it's called. Because if you are doing variations, it means anytime the LLM can generate different variations, and that's not stable for the multi-query, because that's what multi-query is. So we want to make sure that we are very specific, and then make sure we are able to test that. Okay, so now I said we set the marker pytest.mark LLM. Okay, that means that this test will only run if we say Pytest run Pytest minus M LLM. That's, it will run only the markers for LLM. If you say not LLM, then it will not run this test. Okay. Now another one is the parameters. Okay, parameters. Okay, all right. So this one allows you to run this test for multiple data sets. We have a lot of data sets, right? All our answer question pairs, right? This test allow you to run for each of them and collect the answer. Okay, This parameterize allow you to do that. Okay, so you put it at the top, then you define how you get it. You see, you load the golden data set. Okay, you load it, and then for each of them you get the question. All right, then you go in here. In particular, the answer is grounded. It's going to take each of the questions and get the answer and the context. So for answer, context equals rag.generate the answer. Okay, when it's generating the answer, this question needs the question. The question is in the item, and then the retriever function, we are going to use the retrieve, this one, retriever, without using the multi-query. So here we will get the answer and context for one question, okay, at a time. Okay, because of the parameterize we did over here, it will take one question out of it, okay, from our golden data set, and then we'll get the answer for it, and then it will form this sample, singleton sample. This is a RAGAS function. You can use singleton sample. The user input is this question. Remember, we said RAGAS, the evaluation data set, you need to get the user input. You need to give it the retrieve context, which is the context. Okay, and then the response, which is the answer the user has given, and then the reference. The reference is in the golden data set. Okay, that's what it is. Okay, now we have this single one, right? We go and score it. Okay, we score that particular one at a time. Okay, so the score equals the name. Okay, RAGAS matrix name dot singleton score sample. So this function, RAGAS the singleton, the matrix you can score just that particular metric. You take one metric and score it for this particular data set. Okay, this is one at a time. You do it for it. Okay, for name in threshold. So this single response, you take every metrics here in the threshold. Recall, faithfulness, answer score, and score, and get you get its score. So the first one will be like the name. Okay, so the name. So the first one will be context recall. That will be a context recall. We get it, and then we will score the value. We get what is the value of the context recall. Then it will go to the next one, which is faithfulness, and then we will get the faithfulness score. And then you go to the third one, which is answer relevancy, and then to get the answer relevancy score. So for just that simple question and answer pair, we got all the metrics for it. Okay, so we have all the metrics. All right, we can see we have the values of the metrics. We can check to see if the values are greater than the threshold, these thresholds that are defined. Okay, so this is just failures. So if you want to find a failure, we say we have the failures. Okay, we have the failures for name score in scores.items. If the score is less than threshold.name, we want to put the name of the matrix and its value. Okay, this is the score value less than the metric name. Okay, now this is just us collecting all metrics that have failed the threshold. It means they are less than the threshold. That's all that query is doing at the top. This is just that query. But now the place of Pytest is where we are going to assert. We collected all of them that have failed in this. We are asserting not failures. Assert not failures means that we are saying there should be no failures. This is a list, right? This is a list. Not failures means that it should be an empty list. Okay, assert not failure. It means that it should be an empty list. So if this is not an empty list, that means there's a failure. Okay, so in RAGAS, when you say you put your assert and then you say comma, whatever you put after the comma will become up if there's a failure. Okay, so you say if assert not failure, so if it failed, then give this information, and the information you want it to give is this. You say the question the answer, the fair metrics, and all scores. So this is the information you want to write out. Okay. This is the test. So this is the test. Okay. This is how you build the test. So you build this test and then you can run the test. So now that test is built over there. Okay, that test, we are looking at all that test, and then you can run you build the test. You are not calling the test. You just run Pytest and it will run the test. Okay, we build the test. This is just this one. I'm running it from the notebook because this is notebook. You can use a sub process to run it. So we use a sub process dot run, which is Python. So we run it. Okay, what we are running is executable, and then we say the -m. Okay, and then Pytest, we're running it for test folder, and then -v, -m, and then LLM. Okay, these are all parameters. The LLM. So instead of say Pytest -m in the command prompt, you say -m LLM. So this is a sub process. You are just running this in a sub process from this notebook, and you say, okay, give the outcome. When you run all the tests, you want to put the outcome in here. So this, you want to put JUnit XML equals test Pytest results LLM. This is the name of a file. You are just saying that if after running, put the output in this file. This file is here. I'll show you what it is. It's here. Okay. Capture up to true, test equals true. This is a sub process, so this is not something to worry about. But in a CI, this will all run easily. Okay, then we all print it out. So when we run the test, for example, right? When we run the test, okay, it's run for each of them. So beginning test, this one pass. So one is the test is, when it passes, it will be green. Okay. Okay, then the second test also passed. This one also passed. This one failed. So who founded Kente Code AI? Failed. Because what? We say who founded Kente Code AI before, when we are looking at the top, it was 0, right, for this particular metric. The metric here. Okay? Who found it failed? It failed because so you can actually, it gives you details here, failures, you see. Test answers correct and relevant. Who founded Kente Code AI? You see. What actually failed is a item question. Who founded Kente Code AI? Okay. Then the grounded truth in it is here. What we have in the golden data set is here. Okay. Then it tells you which metric, the RAGAS metric, that is failing. Context precision. LLM context precision with reference. It tells you this metric is the one failing. And this one is visual. Remember when we ran it, at the top, it gives us 0 for the same metric. We got 0. We got 0, right? So what happened is, because this metric returned 0, but our test case is saying that the metric, the lowest value is what? 0.5. It failed. Okay, it failed. So because of that, it gave so 7 have passed, 1 have failed, 2 warnings. So normally, because we are writing into the file, you can see like this. But in our real production, what happened is these things will run in the CI, in the continuous, in like GitHub Actions, and you can get those artifacts and save it in your CI so that you can check it out later. So that is what we are going to do. Actually, what we are doing here is in Notebook. It's not the right way. We are going to build, when we build our application and we will build the Pytest, everything will be in the CI, in the GitHub. So for example, like this, you have a workflow. We will talk about workflow files in the next deployment session. You have a workflow. You can schedule this to run daily, or you can have something that triggers it anytime somebody is trying to merge the code into the main branch. and you can define what to do. For example, right? So this is the job. RAGAS regression runs on Ubuntu latest. The steps use this. This is GitHub Actions. That's something we are going to do when it comes to deployment. Next thing on our pipeline after this is the deployment. How to push this into deployment. So it gives, this is the GitHub workflow, for example, it installs the Python requirement that we have and then run the Pytest LLM component. So like this can run and then generate all the things for you. You then save all your OpenAI and Python key in the GitHub Action, and then you can use it to run it. After that, it will upload the artifacts for you in the GitHub. You can go there and check it or use whatever it is, okay? And then the file names you want to add. So those will come in the CI notebook. Was is these things normally we write it as part of our CI/CD, and then anytime there's PR, it will be checking to make sure that everything is right before you merge it in the main branch. Or you can, if normally production, well, if you want to deploy the code into production, you can set up a process that is testing to make sure that monitoring, writing these metrics to see if something is not working correct. So that is part of the regular workflow that we do. So in part 4, we are completed with how the evaluation works. It's one of the things that a lot of engineers, developers run away from, because it's like you are trying to test when you're supposed to be developing code. That's what we think most of the time, that we are developers, not tested. But this is what is going to make your application solid. So we look at the interactive RAGAS, and we see how we can automate the RAG quality test using Pytest. It's very important to use this kind of approach in order to have a solid application. So in our next lecture, we will look at how to actually combine all these things that we have learned into one application. That does, we have the ETL pipeline to index it, the RAG pipeline is here, and then we have the evaluation is already there. So we put all these, and then we have an API on top of it, and a UI, a Streamlit UI is fine, and then put this into GitHub with GitHub Actions on it, and deploy the entire thing. So we're going to deploy the API on Vessel. That's what is going to happen. We're going to deploy the API on Vessel and have the UI running on Streamlit, talking to Vessel. I mean, the index is already in Python, so we can see this live. So that is the goal of seeing this, everything that we talked about come together as one piece. So thank you very much for watching this lecture, and I hope to see you in the next. Thank you.